It's really like if you look at the ribbon, there's this weird texture imprinted into the ribbons, and that's like one of their main selling points, that they have some energy dissipation texture or something. Yeah. And I've only seen pictures, Parker. You had the real thing in your hands. They look like half of the material is super glue.
You mean the driver itself?
No, like the baffles and everything.
Oh, they are glued together.
And if you look at the Six Moons guy, he took a factory tour in I think Serbia. They're located, and there's like bottles of super glue everywhere. Like in every picture, there's cigarettes and super glue. It's really, you gotta check it out on Six Moons. The RAL factory tour. It's like cigarettes and super glue.
They're all high on glue.
See the pictures of the where they make the actual amplifiers.
It's
Like,
probably the same
The
place.
amps and the phone. Yeah.
It's like the four like old guys in like a room just kind of building stuff. It's hilarious.
Yeah. And like ashtrays everywhere. And
yeah. Yeah, dude. It's amazing.
always wondered what they smell like. I mean, like you get the box and you unpack them, and then like I don't know,
They
they
gotta
smell
put,
like
gotta put
ashtray.
like air freshener in there or something, and it just kind of helps mask the smell by the time it gets to the customer's house. No idea, man. No idea.
All right,
Well-
guys. Yeah, let's get started. Sorry for being late. I apologize.
That's fine.
So we got some guys here. Usually people trickle in as we go anyway, so probably we'll get some more people coming in. But yeah, everybody who's listening, I've already started the stream, but welcome to the Sonic Visions podcast, episode 22 DIY edition, and we're joined by our solder sniffing crew. And so let's just go around with who's in right now, just to introduce yourselves and a little bit about how you kind of got into the hobby and how you got into the DIY portion of it, what your job is, that kind of thing. So the infamous Parker, can you start, tell us about yourself?
All right. Well, my name's Parker. I am senior engineer of a company an audio company in New York called Soundsmith, where we make phono cartridges and electronics and speakers and do a lot of equipment service. And I've been working there for almost 4 years now, and it's very challenging. And I've written about it before, but it's also very fun. I guess what got me started in DIY was it goes way back. So when I was a kid, my dad made this beautiful free driving pond boat. It was this little tiny boat with a motor, and you angled the rudder and you turned it on with a knife switch, and you'd put it in the pond and it would do this circle. And the wiring was so elegant and so gorgeous that it was just an inspiration to do things beautifully and create electronics in a beautiful way. And that was basically the fundamental basis for what started me in soldering, because I wanted to be able to do stuff like that.
Cool.
Nice.
Awesome. Okay, and Radioactive Dave, what about you?
Radioactive is radioactive. Well,
Oh, sorry.
No biggie. Well, I'm from Austria. I don't know if that matters. I like my most recent job description, I think, is technical officer in a patent law firm, and I have a desk job, so I need a creative outlet, and for I don't know, at least 2 decades, I would think this has been DIY electronics. I've been DIYing like since forever. As far back as I can remember, I always liked taking things apart and putting them back together with more or less success. Soldering and really working with electronics is something I picked up maybe 20 years ago, is when I bought my first soldering iron. And I can't quite describe what really pulled me towards audio DIY, but what really started it is I bought a broken receiver along with a service manual off eBay and tried to fix it, but soon realized that this would not be the direction that I would like to go in, because I saw an appeal in simple circuits, and so I gutted the thing and started building smaller projects from that. And well, yeah, here we are.
Cool. That's awesome. Void, what about you?
Well, currently, when it comes to job description, I'm a independent full-time service tech for audio gear. So I mainly work on stuff from the 70s and 80s, mostly solid state, though. I got my start in vacuum tube radios, of all things, mostly from the 30s and 40s. Started working on that gear when I was about 16, 17, and I kind of meandered my way from radios to stereo consoles. And eventually I started working on like tube integrated amplifiers, power amps, preamps. And eventually I kind of found myself working on solid state gear for people because in my location there's only one other service technician that actually does stuff. He has like a 7-month long backlog. So I was selling a bunch of gear that I had, and a variety of people just kind of found me through there and wanted me to work on their equipment. And so I started working a lot more solid state equipment about 3 years ago, and have been doing that full time ever since. It just kind of happened. And I got more into DIY after the fact. So I've been DIYing some various equipment. Like first thing I DIY'd, I think, was a B1 preamp, a Pass B1, which is it's kind of like a hybrid between a passive and an active preamp, because it doesn't have any gain, but it also it helps impedance match the source and the amplifier together. So it helps the signal path work a little bit better in that regard. So I've just been DIYing since 2021, 2020. When you're a service tech and you're a full-time one, you end up having to custom make certain things for yourself because the gear just doesn't really exist in any capacity, or if it does, it's certainly expensive and hard to find. So that's where I started DIYing things from, was just a need for that kind of equipment, and it's the fact that it just wasn't available at the time. So that's it.
Okay, cool. Thanks a lot. And SP Wath, I don't know how to say your name. What about you?
Yeah, I don't do as much of the like electronics DIY stuff. I do minor things with that, but not too much. But I've got my Trolls Grobson Lumina 66 speakers I built, and I just kind of got into all this DIY stuff just, I don't know, for fun, getting things on Craigslist, fixing them up, and then built my own speakers now.
Well, what kind of speakers have you built?
I just built the Trolls Grobson speakers, the Lumina 66. Yeah, that's all I've built. But planning this summer to maybe build something else. I don't know what yet, but something big. Maybe try designing something more on my own.
Cool. Sounds good. All right, well, let's start with some questions, and you guys feel free to jump in and kind of go in a different direction if you want to. But what's the scariest encounter you've had with electronics and DIY?
Well, this is a good one. I guess I'll go first. The scariest... Well, I've had a couple brushes with death working with electronics. And I guess going back, the earliest one was, I think I was 14 years old. I was working at a hobby shop, and they saw that I was good at soldering. All my solder joints were coming out very shiny. So that what they did was they said, "Here, Parker, wire up this 5th scale electric RC car with two 14.8 volt giant batteries." So what I did, they're like, make a wiring harness to wire these in series. I was 14. I didn't know what series and parallel was. So I ended up making this triangle harness, and I plugged these batteries in, which were about the size of a shoebox each. And I ended up plugging the positive terminals together, and these brass bullet connectors the size of my thumb vaporized in front of my face.
Wow.
It was like Dragon Ball Z. I was holding these connectors, and it was just this ball of light in front of my face. And it roasted all the skin off my hands. It burned the skin off my face. It was just this blast of explosion. It actually like burned the meniscus off my eyes. It was insane. I went to the bathroom. It looked like a cartoon, and the batteries were undamaged. The car was undamaged. It just eviscerated these connectors. They literally turned into particles. Yeah, that was the first.
That's crazy.
That was the first experience with the power of electricity. Another one would be, I mean, there's more, but the second most powerful is coming to mind when I was servicing a CO2 laser, and I didn't discharge the power supply. And since this was a very inexpensive unit, there was obviously problems with it. And one of those problems was the lack of a bleeder circuit in the power supply, and how the thing can maintain a full 30 kV charge on the positive terminal connecting to the CO2 glass fitting for the CO2 laser. So I was working on it, and I opened the lid, and I was probing around and undoing the positive connection, and an arc jumped from the sheathing of the wire to my cheekbone. So this was the full power supply discharge.
Wow.
Yeah, it went right through the sheathing. It was incredible. And 30 kilovolts is like a taser. Hit my cheekbone, my vision went white, my hearing was gone for a good 5 seconds. It was just ringing.
Holy crap.
Yeah, that thing really got me. And I slammed the lid shut. Everyone's like, "Oh my god, are you okay?" And vision comes back. It was literally like a video game, like how they do flashbangs in a video game. And that's what it's like to be tased in the face.
Whoa.
I'm surprised you continued in the hobby after such crazy experiences.
Oh, those are nothing.
Okay, what about you guys? Void, Radioactive, SP?
Mine
Radioactive.
personally, I think I was 17 or 18. I was working on a Philco radio from 34, and I was working on the power supply. And unbeknownst to me, I had the power on when I was working on it, and the thing has a 600 volt rail for the power in that thing, and I kind of touched it with my right hand, and it sent me across the room, and that was
Wow.
that was pretty hilarious.
Holy.
Having experiences like that kind of teaches you to be a little bit more careful about what you're doing. Yeah, you kind of, when you work on tube gear, you kind of it comes with the territory. So
Yeah, you
you're
gotta
bound to
have
shock
one hand
yourself.
behind your back, military style.
You see, I was a teenage idiot. I didn't really do that. So I learned after that. But yeah, that's my most memorable electrocution moment, I think. No.
High voltage is what really scares me, because it's, yeah, I can deal with high amps, like low power and high amps, but high voltage is really, I don't know. This has instilled respect. into me. It's obviously hard to follow these stories. I don't really have any spectacular negative interactions with electricity. One that stuck with me though is from a holiday in Italy when I think I was 11 or something, and they had this gas stove. You were mentioning them earlier, Parker, and they had this push button thing that would turn on an arc supply, which would then light the gas. And I was toying with it, and it had like maybe an inch or something of an arc discharge going to the gas burner, and I decided to draw the spark to my finger, and it went right through me into the ground, and I could feel the muscles like from the tip of my finger all the way to the toes, everything contracted, and I got the air pushed out of my lung, and like it was intense, and it felt like my finger had popped off, and every single joint from my finger through the elbow, shoulders, hip joint, knee, ankle, they hurt for like 3 days. I'm not sure how much voltage or how much amps went through there, but it was painful, and it taught me a very valuable lesson. Like, don't fuck with high voltage. It's really that's the thing. I mean, you can touch anything with 12 volts pretty much if you don't have like actually wet hands, but with high voltage, it's that it just jumps on you. It's yeah, and the other time when I don't know, I had some brain fart moment and decided to bend a nail and grab it with a pair of pliers and like stick it right into the power outlet. We have 220 volts here in Austria, because I thought like, yeah, well, we have like a fuse. It will trigger the fuse. I want to see what happens, and what happens is part of the nail evaporates before the fuse triggers. And it made
Slow
a
blow
really
fuse.
huh.
The fuse must have been a slow blow.
Yeah, well, it was the circuit breaker actually.
Oh.
Yeah, and like half molten power outlet, but the sound really stuck with me. It was like some fat smack and like a small blue flame. Yeah, I sometimes wonder how I got to grow this old, but yeah.
All right, so those are some pretty crazy stories. What next question is, what are your guys' favorite completed project? And then also, what project have you been putting off that you kind of want to eventually get to?
Oh my god.
That's hard, dude.
That is a hard one. We all have
Especially
multiple
without show and tell.
Show and tell. Huh. Well, I guess I'd have to say my favorite is audio related. My favorite completed audio project would be the headphone amp preamp that I use every day. And I really like it. And I've posted pictures of it before. It's basically a modified CMOI amplifier with a crossfeed circuit, a natural taper crossfeed circuit that's selectable. You turn it on and off with relays. And the reason I built something like this is because I just wanted some good features, and I wanted to never have to turn it off. I just wanted it to work all the time, never have to fix it, sound good, and never break. I know that was redundant, but that's like one of the most important things, was to just be able to turn it on and never have to touch it again. So I guess that's my favorite project right now. I don't know. What was the other part of the question?
What about a project you've been putting off that you could have been procrastinating on, or that you maybe it's a partially done project and you still have to finish it?
I've got like 30 of those.
We all do.
Yeah.
Yeah.
What comes to mind, I'll just name an interesting one, which is I have a handheld cassette player by Toshiba. The name of the device escapes me. It's on my workbench right now. It was featured in the Terminator movie. I think it was from 1984. And I have the exact model. Not the specific one that was in the movie, but it was the same one from Terminator.
The one that he's using when he rides away on his motorbike.
I believe Sarah O'Connor is the one who's holding it in the shots. Oh. It's a Toshiba something, but inside it's gorgeous. It's as nice as any high-end Sony portable cassette without the recording features. So Sony had a few that would record, but they also had a few playback only. This Toshiba's playback only. It had a very interesting feature where it has pins in the bay for the cassette, where you could get a radio tuner in the shape of a cassette made by Toshiba, and you'd snap it into this Walkman device, and then you'd have FM. And it was very cool.
That's the first time I'm hearing of something like that. That is pretty neat.
Yes, it was beautifully made. Inside is some beautiful cast aluminum flywheels and brass machining. It's all balanced. It's gorgeous to look at these machines. They're like a fine watch.
Cool.
Nice. Anybody else? Why don't we just focus on? Actually, by the way, Sunny just came in. Hey, Sunny. Thanks for joining us. You want to just kind of introduce yourself and kind of how you got into DIY and your current job and that kind of thing.
Oh my gosh, can you guys hear me all right?
We can hear you.
Okay, I'm using Galaxy Buds, so God knows what it sounds like. I just love it. Let's see. I got into DIY because
you're cutting out.
Oh no. Oh.
This may not work.
This may not work. That's.
Might have to wait like 5 minutes until I'm home. And then
get a headset or something. We'll be here.
Yeah.
All right, we'll come back to Sunny. So let's focus on favorite projects. Anybody else with a favorite project?
Well, my favorite project still is the first power amp that I ever built. It's one of the projects of Nelson Pass, the Zen Light, which is using a light bulb as the load resistor for the transistor for the active element. And on paper, it looks really simple. It has like a transistor, two resistors, and like this light bulb, and like a couple of caps and a rectifier in the power supply. But if you build it in real life, it's like it took a whole table. Like, I don't know if you guys know these luck tables from IKEA. It's like I built it on top of the table, and it's like huge and heavy and awesome, and like the light bulbs, they glow when the current runs through them when the amp is on, and it's like I completely misjudged the project, completely underestimated it, and like a couple of months ago, I had to put it away some years ago, but a couple of months ago I built a modern version of the light bulb amp for headphone listening. Actually, some of you have seen the pictures. Its thing is huge and dissipates like, I don't know, 200 watts or something. It's completely senseless, completely over the top, but it's a cool project, and it's huge and wasteful. But like for an hour or two over the weekend, it's just perfect.
Now I remember you re-engineering the ground scheme for that device.
Oh yeah, that was a hard one. To get quiet for headphone listening, that was. I'm still proud of that, actually. Yeah.
Yeah. So tell us what you did.
Well, what did I do? The power supply, it's just full wave rectifiers with huge capacitors. I think it goes somewhere up to 60 volts, and there are, I think, 8 caps with each 33,000 microfarads. So it's something you'd see in a huge Class A power amplifier, which it basically is. And with these caps, they have screw terminals, and you have to collect the ground somehow. I first tried to make a star ground with wires, actually, wires and these eyelets that you can put on the wire, and connecting that with screws. But then you have like a vertical distribution with the eyelets being held together by the screw, and you get currents stacked, and I couldn't get the thing quiet enough for headphone listening. I mean, quiet enough means absolutely inaudible and preferably not really measurable. To what brought the solution was using a plane. Like it's a I don't know, in inches, it's so hard to tell. It's like half a postcard sized piece of aluminum. I drilled holes in it, and I connected the ground return wires from the caps, from the speakers or headphones, input grounds, everything onto that plane, and the currents they sort out themselves, and that I think I got it down to like 50 microvolts of noise. So it's one of the most quiet. It is the biggest amp I've ever built, and it's also the most quiet one, which I really did not expect. It took me probably 2 weeks of troubleshooting to iron out the ground hum. But yeah, ground plane, even with huge discrete components, if all else fails, ground plane. Yeah.
So that's actually pretty brilliant, because what you did was you created a solution where the current return path to ground kind of balances itself. Instead of having them stack up on top of each other, you had them kind of finding their own path through a piece of aluminum.
Yeah.
Which was extremely clever, because any sort of differential ground return impedance will actually cause noise, which you figured out. So that was an extremely elegant solution, and it's something that we should all learn from.
And interestingly, this is something you would never notice with speakers. Even if you put your ears right next to the cone, they simply lack the sensitivity that you have with headphones. It's a problem pretty much specific to headphones, and unbearable with headphones. You can't have hum with a tube or valve amp maybe, but not with a solid state device. These have to be quiet. And yeah, this was one of the better troubleshootings. I mean, the solution was simple, but very effective. Yeah.
Well, it was not simple, because it took a long time to figure it out, but it was elegant. There's a difference.
And a nice detail, the metal plate that I've been using for the ground plane, I had like an L-shaped bracket where I made a cutout for the for the receptacle for the mains power and switch. And
yes,
the leftover piece from the cutout, that's the thing that's collecting the current.
Oh. So it's sustainable as well.
Yeah, it's a state-of-the-art dug out of the trash.
Yeah, well, that's brilliant.
Any other favorite projects?
I don't think it'll be as cool as that. About a year ago, a friend brought me a Yamaha power amplifier, but this wasn't like a normal Yamaha power amp. This was the biggest one they ever made. the PC 5002M for anyone who cares to Google it. Thing weighs like 140 pounds, and it's basically a two-man job unless you're like a bodybuilder or something. And I had to completely rebuild this thing. It smelled like nicotine from about 10 feet away. It was used in a bar for like 30 years. So the thing was caked in nicotine. It was caked in dirt. I had to basically take the whole thing apart. There's literally layers of boards inside of the thing. I basically couldn't move it across different tables. So I had to get the owner to stop by and put it on the actual workbench. So when I was done cleaning the thing, which took me like probably 4 or 5 days.
What's the
off and
process?
on.
Like, what do you use to sorry to interrupt, but what do you use to clean nicotine smoke and like bar grunge off of an
Well,
amp?
on the boards, I thankfully the boards were designed in a sensible way to where some of them could be removed from the unit. So I ended up using like 99% isopropyl alcohol because that'll clean pretty much anything off those boards without damaging the components and the plastic connectors so that's what I used to clean the boards. For the case and for the metalwork, I basically took off as much as I could on the thing, like any side covers, trim pieces, and I just used simple green, and I would just basically scrub the parts because they were just everything was caked in nicotine, just everything, every inch of that unit. There was just nicotine dust and grime everywhere. The front panel was sticky. It was really disgusting. I'm gonna be honest with you. It was horrible. It worked, by the way, which is pretty hilarious.
What brand capacitors were in there? Was it all Elnas?
Yeah, I believe they were all green Elnas, if I remember correctly.
Green
Sure.
ones. Wow, that's
Yeah, the 105
that's surprising that they actually
it
still
runs
work.
hot. It runs really hot. Like all the driver circuitry is super high biased. So they threw high heat caps everywhere for reliability because getting access to some of the boards is an insane amount of labor, and I'm assuming they just never wanted the circuits to fail because if they did, it'd be really hard to work on them. So I just had to go through every single inch of this thing, and my friend still uses it. He's been using it for over a year now. It's been done for a while. He's using it on Magnapans, and it's a 500 watt per channel amplifier,
Wow.
and it'll almost double that into 4. It's a ridiculous amp, but that
So
thing probably
almost
took
enough
me
power for Magnapans.
almost enough. The thing took me 4 months, like off and on, to complete, which is probably the longest runtime I've had for any single individual project. Most stuff leaves here pretty quickly, but for that thing, I just had to work on it for a day or two, stop, work on it, stop. Otherwise, you just kind of burn yourself out because you're looking at the same thing for weeks. And you make mistakes when you do that. And I found that if I just walk away from it for a little bit when you're working on massive projects like that, just do something else for a day or two and clear your mind and then go back to it. But that's probably the most impressive thing I've ever worked on. And it was super satisfying being able to put it together and power it on and listen to it because it sounds pretty fantastic. It's just a monumental amount of work to get them all rebuilt and up to snuff. So
Yeah, it's an amazing rush when you get that. Yes, it's working. You know, the first power on. It's like after a restoration or after you've built something, you just power it on, and it's like, hell yeah, that's what it's about, baby.
yeah, and
Yeah.
with shorter projects, you kind of get used to that. Like, you know, you work on something for a week and you get it done. It's like, that's pretty cool. But when you work on something for months on end and you power it on for the first time in probably 2 months and you're crossing your fingers and you hope you didn't wire something backwards or get something wrong and it works, that's like the best feeling in the world right there.
Yeah,
So-
dude. When I re-engineered the Meridian CD207, that took me 8 weeks of 8 hours a day reverse
Oh
engineer.
my.
You know that they had a service manual for this thing. Meridian actually gave me the service manual. Take a guess. I want y'all to guess how many pages this service manual was.
150.
4.
2?
750 pages.
What?
Oh, whoa.
My
Oh,
boss printed it out and threw this stack of papers on my desk. And I was like blown away. I said, "This is what they sent us. This is what they gave us." And I read the whole thing. I read the entire thing. I went through every page and I made notes. And I still have, when I buried the project, I made 3 working samples out of 7. The Meridian CD207, for those who don't know, is a CD transport and preamp in one unit with a phono stage and a remote. It uses a TDA 1541 DAC with a multiplexer chip and a Philips CDM2 laser, and all the boards are proprietary. Normally when they would create a device using these things, they would just use the Philips circuit. Meridian engineered their own like laser driver, their own multiplexer, and their own D2A reconstruction filters, and it was all nuts. And through the process of 8 weeks, I ended up getting like a decent understanding of the machine, and I was able to effectively troubleshoot them. And out of a bunch of broken units, I had 7 broken units, and I was able to make 3 working ones, 2 of which went to customers, and 1 is still at Soundsmith. I forget where I was going with that, but yeah, it's an incredible rush once you get it working. After 8 weeks, I literally jumped up on my desk. Eureka!
Can you hear me now?
Hey,
Yes.
Much
you're
better.
audible.
Yes, Sonny, go ahead. So tell us about yourself and how you got into DIY, and then maybe a favorite project of yours.
Sure. So I guess I'll do that in order. Currently, I'm an attorney. That's why I was late, because I work a lot and I went to happy hour. Getting into DIY, I play guitar and I wanted to start building a pedal board, but the guitar pedal market is a racket. They, charge hundreds of dollars for like 4 components with a button on top to step on. So I figured, if I could get like a schematic, I have a basic understanding of how electronics work. Why couldn't you just clone something like that? So then later on, and I did, and I started, I'd print the schematic on a piece of magazine paper and then iron it to a blank copper board, throw it in hydrochloric, etch it away, wipe off the laser toner, and then you've got your little makeshift PCB you've made. But then for headphones, I had like Turtle Beach crap and all the typical gamer stuff for a while. And then actually through Google searching, I got the HD 600 as my first like legitimate headphone. So I kind of lucked out there. I didn't end up on, like a HE 400 or something. And from there, I started reading about like, oh, you need an amp to really, because I was just plugging it into my motherboard. And I thought back to the guitar pedals and thought, well, I wonder if this is one of those situations where you can, save money on paying a company for 8 pieces in a box and do it yourself. It's not really the same as a guitar pedal, but I like doing it anyway. I stumbled across AMB, TCAN's website and forums, and I did a CK, what is it, CK32, or is it CK2, whatever it is, the Cavalli AMB, collaboration, and then I've kind of gone from there. My favorite project to date, that's tough. I mean, the current Sunigaku project's kind of fun because that's kind of my own design to a point. I've tweaked enough of it and actually start to finish making the PCB, doing the case, etc. has been kind of neat. But really, my favorite project to date is the Valve DAC, which someone else in this chat, that should have been your answer to the thing you've neglected.
Yeah. Which I did not talk about at all.
I know. He actually bought like one of the last FPGAs on planet Earth that was compatible before I did. But thankfully, the founder of the project is not only a genius but an angel, and he rewrote all of his code to fit onto a different FPGA just so I could get my unit running. Because the Valve DAC uses an FPGA to take PCM data and convert it to DSD, because it's not, I feel like every other tube DAC, quote tube DAC, that you see is just a chip DAC with a tube output stage, and they slap the name tube DAC on it. This actually uses the tubes for the DA conversion, but obviously PCM data is worthless for that. So yeah, that's my favorite project by far. And yeah.
And it looks good too. Tell us about the casework.
Oh yeah, Landfall. If you guys don't know Landfall, Texas-based company, awesome to work with. Oh my god, I knew nothing about 2D CAD when I was doing everything in Illustrator, and they basically fixed all of it. Worked with me every step of the way, and it turned out really, really aesthetically pleasing. It's yeah, it was definitely my favorite project overall. Especially,
sorry to interrupt. What program did you use 2D CAD?
Oh, for this, it was all Illustrator.
You did this in Illustrator. You didn't actually like make a file directly. I don't know.
Well, because it can export CAD files. They just apparently they suck, and the Landfall people had to redo some elements of it. For the Sunny Gaku, I had a trial to BricsCAD, and that was actually kind of nice, but that just expired. I'm too cheap to spend $1,000 on a CAD program.
Yeah, don't do that. Just do Fusion 360.
Fusion is like, I mean, I am using it right now for something else, for my eddy current
for the
project. No, for casework. No, for PCBs, I just use KiCad. KiCad's pretty great, but no, Fusion has the absolute worst user interface of all time. I don't know anyone out there has used Fusion, because
I do it a lot for 3D models, not so much for electronics.
Even 3D, because I don't know if you guys are aware, AutoCAD's the hardest thing on earth to pirate.
It's
or not AutoCAD. I'm sorry, SolidWorks.
Yeah, SolidWorks is impossible. Well, I actually did manage to do that.
Well, you can, but you gotta be careful, because if you send your file to someone else, it will alert, the company that they're opening a pirated file. And
yes. Except if the other person's using a pirated software, then it doesn't matter.
What I did, I have an external drive that I installed a separate Windows on with just SolidWorks, and it's totally network isolated. So that's how I do all my degenerate projects. But yeah,
just putting it out there, I do my 2D and 3D drawing in Tinkercad.
Tinkercad is very easy to use and free, but it doesn't have the advanced features of SolidWorks and Fusion.
Obviously, no, it doesn't.
However, for casework,
yeah,
for casework, it's excellent. That's a brilliant idea.
That's really all I need it for.
One sec.
Have to give it a shot.
Tinkercad, it's online. You can it's like all the rendering and everything is cloud based. Like you can 3D design, 2D design on your mobile phone, because it's not locally processed. It's all online. I don't think you have to install anything. It's all in the browser.
Yeah. I've
And
seen
it's
a
free.
bunch of architectural models done in Tinkercad as well, so you can actually get some pretty advanced shapes.
Okay, let's go into electronic mysteries. So, what is a kind of a bug that you found that was very very strange that you managed to solve, and what are some bugs that you still haven't been able to solve that are kind of something that you're perplexed by?
So I have encountered there was one bug that it was pretty obviously looking back, pretty obvious looking back. I built a line level analog crossover based on unity gain buffers. I think it's called the cell and key filter, and it uses a pair of JFETs. It's like the B1 that Void built. A few of them stacked in series with feedbacks, capacitors or resistors for high and low pass. And it's a very compact build, really. It's like you can't, like with discrete components, you can't build it any smaller. And measuring it some days it seemed fine, and some days I had some mysterious offset at the output, and this is a classic sign of high frequency oscillation. And when I looked at it the circuit oscillated at a couple megahertz, and like the slower parts seem to rectify it and put out the envelope of the oscillation. So you see some strange DC offsets at the output that shouldn't be there. And the cure was putting a gate stopper resistor at all the gates, and all that it took was like an inch or half an inch of exposed track that was messing with the input capacitance of the JFET to get the thing oscillating, even without gain or anything. It was really, I did not expect it to happen. It's a unity gain circuit, nothing much happening, audio frequency driven. But the lesson here was definitely JFETs do really need gate stoppers. Yeah, looking back, it was a bit sounds trivial almost, but yeah.
That's an interesting thing with feedback circuitry is that especially if you're doing like a analog filter using active components with an op amp, if you are varying the gain by adding filters in your feedback circuit, you have to be very careful not to create a resonance. Otherwise, the bandwidth of the op amp it'll just go directly into oscillation.
Yeah, that's the thing that people always neglect, I think, with op amp rolling, is like what's the bandwidth of the new op amp and how is the design taking that new op amp. So putting newer high-speed op amps into older designs can lead to unwanted consequences and changes in sonics in that.
And high-frequency oscillation on the output of your amplifier.
Yeah. Yeah, well, and one mystery that I have not been able to solve was I was lucky enough to find or to come upon two Macintosh MC75 monoblock amplifiers with consecutive serial numbers, and one of the units has a higher power draw. I replaced all the caps, I replaced all the resistors. The problem does not migrate with the tubes. Usually when you have two channels of something and one channel has a problem, you try to flip everything, like switch input connections, switch output connections, switch out parts. With tubes you can do that. You can put the active device from the right channel into the left channel. See if the problem follows with some part, with some interconnect or anything. In that case, it did not. One unit draws more power than the other, and the transformer has a very slight hum that I have not been able to cure. They run off the same step-down transformer, so it's not the supply, it's not the load. I think it must be the transformer, but that one will probably remain unresolved because these are tar-potted transformers, and they are far from trivial to like take out of their potting and have a look at.
Oh yeah, and especially the fact that it vibrates while it's potted is concerning.
Yeah, that's unobtainable. I'm just letting you know.
Yeah, you can't even buy those.
I've worked on a couple 75s. The only thing I could tell you when it comes to uneven power draw is tube biasing on the outputs, because those things do use a selenium diode for the biasing circuit.
Yeah, that one went into the trash. I replaced it with a UF007. I don't trust selenium rectifiers.
Yeah, I mean, one way to rule out the transformer being a problem, because if it was drawing excess current, there would be like an internal, like a intermittent or a high resistance short circuit on like one of the windings or something.
Yeah, there's some losses. It's a couple of watts, but it's repeatable.
Yeah, it's
a couple of watts. That's interesting. If the transformer was compromised, it wouldn't be a couple of watts. It would be like extremely messed up.
Yeah.
So it might not be the transformer. It might be something else drawing a little too much current.
Yeah.
Yeah, they measure too similarly, and the transformer really does give off hum. I mean, every other month I'm going on eBay and checking if someone sells a MC75 transformer. I mean,
Well, what you can do is
you can eventually.
You can lift the transformer from the circuit and take static readings of the two and just see if they measure differently.
Yeah.
Yeah, that might be the thing to do. But
see, I have DATs, so what I would do is I would run an impedance sweep of the primary and secondary windings and just see the back EMF and just analyze their parameters and see if they're matched.
That? Yeah, that would be an option.
Yeah,
that one's bugging me. I mean, I'm not using these amps because they're too huge and way too much heat and everything, and tubes are kind of wasteful. Good tubes. I spend way too much time listening to stuff, but that one will follow me around for.
Your mystery's so much more interesting than things I've had. My first Sunigaku, I could not stop the buzzing because it uses a ladder attenuator, like a relay controlled ladder attenuator, and it would only buzz if I engaged it at all. So it 0 dB when it's just a pass through, essentially, no buzz. And I was like losing my mind, and I am an idiot and forgot that. So for those that don't know, the new tubes are like the most sensitive devices humans have created to date. And the retail Sangaku, literally, if you cough next to it, it will ping, like an audible ping in whatever's connected to it. So all of the PCBs in my Sunigaku are on rubber standoffs. So the attenuator board wasn't grounded like I thought it was because I've never used rubber standoffs and just completely forgot to address that problem. So I took a wire, touched it on like the nut to one of the rubber standoffs, and then poked the case. No more buzz.
They usually ground the stand the circuit through the standoff to the chassis, or how does that work?
Right, and I'm using all rubber standoffs to because when the even though
mounts.
Yeah, so that when the relays pop, that sends vibrations down through the board into the case. If you use, aluminum or whatever standoffs, the new tubes will go bonkers. And so everything is on rubber standoffs, and I just absent-mindedly forgot that it grounds itself through the standoff. So that was a fun couple days of being dumb.
Yeah, the homemade bugs, they're the best. They're usually the ones where you learn the most.
Or that Studio T that I fixed the eddy current Studio T recently that would not stop eating fuses no matter what. And I checked I even bought an oscilloscope for this thing to keep. I mean, I needed one anyway. And turns out, I don't know how it happened, but it has it has a switch that cuts the mains power, which, by the way, it's on the amp. So it runs mains power through like, I don't know, 22-ish AWG wire through the umbilical into the amp and then back to the isolated power supply, which what's the point of that? Goofy design. But the wire soldered to the on-off switch had come free. Like I don't understand how. It's surrounded in solder. It had solder on it, but almost looked like it had arced at some point and freed itself. I don't know. Goofy. So I had to redo the whole switch, and that solved the problem. But that's not something that you think to check. Like, oh, I wonder if the mains lines are connected to the switch in this retail product.
If it was blowing fuses, that means it was arcing the switch.
Yeah, like the wire it would work sometimes, and I think it was if the wire was just cooperating and touching the switch prong.
You know what happens sometimes is if you draw an electrical arc in close proximity or using solder, it will actually melt the solder and create micro welds, which will later break, but intermittently the part will connect and it'll work.
Yeah, and that's kind of what it looks like when you examined it. I mean, I took pictures of it, so that was the whole putting the main switch on the amp itself when you have an isolated PSU frustrates me anyway.
Oh, now I get it. Oh, that sounds goofy.
Yeah, so it has a 14-pin umbilical from the PSU box to the amp box. And the live line from the IEC inlet goes straight to the umbilical, to the amp, to the switch, and then back through the umbilical to the transformers. So you go through all this trouble to isolate the power supply, but then run mains voltage through the dinkiest wire ever.
He should have put the switch on the bottom unit. What was he thinking?
I don't know. Or I am essentially...
Put it on the power supply.
I'm essentially cloning that. Well, the aficionado, I think, is like that. But I'm essentially cloning this thing and putting dumb parts and snake oil parts in it for fun. And I'm using a relay trigger. So the power button is still on the amp for convenience sake. So you can throw the power supply wherever. But, it's 5 volts or whatever. It's just a low voltage relay trigger to then turn on the mains power, which is how the retail unit should have worked. But, what do I know?
Too much effort, man. I don't know. Maybe they thought the relay control didn't sound as good as just wiring the mains right.
Running mains through 22 AWG through a
sounds better, man. Come on, dude.
All right, Void. What was your complex repair? Something real mind-bending.
I've had 2 in particular. I'll try to make it quick so the segment doesn't go on for like 2 hours. But
I have one that I want to mention. So you don't make it quick. Just I want all the details.
Okay, I had a Dynaco Stereo 70 that came in because the tubes were baking themselves. Like they were getting really, really hot. And this was one that I worked on, so I was really confused. So I take the thing apart, and the tubes are in fact baking themselves. So I know the customer, is kind of sane, kind of. So anyway, I go through this thing, and I check the bias supply, which is what determines how hard the tubes run, and it's supposed to run like -35, and it was running like -5. So it was almost setting the tubes to their maximum power draw, and I was really confused. I'm like, what's going on here? And so I start hearing like these little like arcing sounds, like these little snaps. So I flip the unit over, I take a look at the circuit board, and I turn my light off. And one of the traces that was running right next to the bias supply trace was arcing. And it was arcing through the circuit board. It wasn't like one trace was too close to each other. Basically, what happened was the circuit board, these early phenolic circuit boards will absorb moisture over time, and they'll become conductive in certain spots for whatever reason. And the 400-volt line for like the B plus was arcing to the bias supply, and it was causing the tubes to like red plate extremely hard. And it was intermittent, so it made it even harder to find it. And I literally had to take a Dremel and Dremel out the like arcing part of the board.
Yeah.
And even that didn't fix it. So what I had to do is I had to Dremel out the circuit trace for the bias supply to get it away from that high voltage rail. And I just ran a wire, and that made it work. It was so
That's
weirdest
crazy.
thing.
So the term for that is tunneling. It's PCB tunneling, and you described it exactly the way it happens. It's moisture ingress. The PCB is hydroscopic, or it uses some sort of chemical that penetrates the FR4, and it'll actually become conductive and high voltage. It lowers the breakdown voltage of your PCB significantly.
Yeah.
It no longer becomes an insulator at a certain voltage. It becomes a conductor.
Yeah, it was extremely frustrating, but finding it was hilarious. It was like
So it was like inside the board. Was there no visual indicator?
There was the thing is the board is a dark brown.
Oh,
and there was
it's already burned.
and there was a black spot, but the board is dark brown, and it doesn't stick out. It's not like the board's green and you just see it immediately. You kind of have to look for it. And the second weirdest one was I'm actually working on it now. I had a Macintosh C28 preamp where it was making an intermittent popping sound out of the output of the preamp. And I did all sorts of work to it, and it still was doing it. And I was really, really confused. So I was running the thing, and all of a sudden, the unit was drawing like 5 amps from my power supply. And so I shut the thing off, and I think, oh man, something's blown up somewhere, like really hard. So I start taking some measurements, and there's like a short ground. So I start like removing wires to figure out what it is. And the short circuit was still there. It was still drawing 5 amps. So I thought maybe the diodes and the power supply shorted out. So I removed the transformer wires. So the transformer is completely isolated from everything, and it still drew 5 amps connected to nothing. So the primary of the transformer was internally shorting. It was causing the popping sounds, and eventually it just completely broke down, and it basically turned into a space heater. The thing got really hot. So it took me I've probably had that unit here 2 or 3 times, just because it's so hard. It was so hard to find. It's like the least likely thing you would expect.
Yeah.
And I got the transformer in recently. It's you have to make it work sort of thing, because it's never going to work, or it's going to work, but it's going to have an aftermarket transformer in it. And that's what I get to do tomorrow. So
fun.
Yeah. That's one of the weirder ones.
Yeah, that's the hardest ones to spot, when things don't completely break, but just somewhat and intermittently. Yeah,
especially when the transformer is potted, so there's no visual indicator that anything could be wrong with it. So it's just like Honestly, I'm glad it shorted because that made it easy to find. If it was just popping forever, I would have never found it.
That's like the method we were talking about earlier for finding a shorted component in your amp. You just hardwire the fuse and it'll light, the component will illuminate itself.
Yeah, it'll light up for you.
It'll burn
burn
out
Visual
the bag.
indication.
Yeah. So one repair that I did was on this is just I've had many experiences with really mind-bending stuff and it changes my life. But one that was specifically noteworthy was a Bang & Olufsen Baosound 9000. So what this is it's a CD player with 6 CDs in it, and it sits on the wall or it stands vertically, it'll sit horizontally, and it's got this sled that will go up and down this rack, and it will engage the CDs. So it's got like a 4-foot long folding ribbon inside that moves with the carriage, and it will actually stop and play a CD, then it will go to the next one. And it's a very fascinating machine, and it's very beautifully engineered, but there are so many problems with it. And the inside, this is B&O in the early 2000s, like late 1990s, early 2000s, when they went full surface mount, pick and place. So the inside is all surface mount electrolytics and SMC. Very frustrating. The service information for these, fortunately, is readily available. So I had this machine working. There were a few flaws with clearance for the sliding mechanism. What it would do was it wouldn't disengage all the way, and it would slide across the 6 CDs and put this giant gouge in each one of them. And that turned out to, that was hilarious. You go and destroy 6 CDs in a row, and then I'd try to play the last one. That turned out to be a lifter arm inside the mechanism, had like a slight deviation because it was made out of soft metal. And all I did was I had to wrap a pin with heat shrink to increase the diameter of the pin so it would lift up a 0.5 mil away from the CD and actually have clearance on the top and bottom. I got the whole machine working, so now I'm going to test I want to listen to it, I want to test. The remote doesn't work. I tear the whole machine apart and I'm inspecting the remote board and it looks pristine. I power it up with a power supply and I'm looking for the pulse and I'm tracing the pulse and I find that at a certain point there is no pulse. It's just standard signal tracing procedure. But what had happened was a microscopic trace. Fortunately, in the multi-layer board, it was on the top. It ran underneath the 2 legs of a surface mount electrolytic capacitor. The capacitor shit itself and it destroyed the board underneath it just enough for the trace to be open. So there was 0 visual indicator, and only by using the schematic I was able to tell that this hairline was open. I removed the capacitor, and sure enough, there's a tiny black speck underneath it, and that was the problem, and that was why the pulse was not being amplified to the remote circuitry. I had to use a microscope.
Holy crap.
Nice.
Yeah, that was really crazy. So, the board can be broken beneath the surface mount capacitor. That was what I learned from that.
And this, my friends, is why techs are very adamant about companies providing service manuals for their equipment.
Yes, without the manual, I would never have any idea that trace was even supposed to be there. Because a multi-layer board, it vanishes from your vision. You don't know.
Yeah, this is why we're very adamant about companies providing documentation. Because if you don't have that documentation, you can't really do anything when problems like that happen.
Schematics or die.
Schematics or die.
Well, okay. Yeah, sorry, go ahead.
I just recalled a small bug from my early days in electronics. I built a constant current source that was referenced with a Zener diode that was providing a voltage to the gate of the pass transistor. and it wouldn't turn on. And I checked the whole circuit, and this was the last part that was left where the problem could have been. And well, that was the day that I learned that you're supposed to operate Zener diodes in the reverse direction.
Oh
But
no.
okay, diode, yeah, I want the band gap. Like, come on, conduct current. But no.
That's it. Yeah, I mean, you gotta learn somehow.
Yeah, that was.
You just happen to learn the hard way.
Yeah, but you know, these are the memorable ones. Then-
Yes.
Okay, enough about bugs, maybe.
What is your favorite tool that you like to use?
Favorite tool
Well,
for electronics? Well, I have a milling machine. I like to use my milling machine to make cases for my audio projects. It's very fun.
yeah, you'd think all your cases would be round, you know.
Oh, no, I like to incorporate design elements that I like to see in other people's equipment, like that pass. I forget what the name of that super high end pass preamp is. So like the XP
Yeah, XP something. Yeah, 30
two chassis. Well,
Yeah.
I took that idea of the chassis construction using corner posts, and I made my little headphone amp like that.
Yeah, that's what I've been thinking of, the corner posts.
The problem
And-
with corner posts is when you make 4, there are 6, 7, 8, 10 tapped holes each. And you can kind of cheat. You can tap straight through 4 of them.
right. Yeah.
But you're
Wow.
still doing like 24 tapped holes that have to be in precise locations. If one's misaligned, then your whole corner post is like, well, now I got to drill a misaligned hole in my side panel, and now this side panel can only go on the right side in this one direction. So you really have to make them in a batch process, which I learned. You have to do everything precisely in a batch process so that they all come out identical. Otherwise, you can't like flip panels around on your designs.
I would
Yeah.
say my favorite tool, I'm speaking more as a service guy here. Heiko makes this really cool thing called the FR301. It's like a gun. It's a desoldering gun. And that thing is insane. Like, if you're desoldering stuff by using a hand pump, it literally like changes your life forever.
I was
Like,
literally going to say that.
Yeah, like just it takes a process that usually is frustrating and it turns it into like a 2-second ordeal. And it's not even an ordeal at that point. It's
fun.
It's literally easier than soldering the part in. Like, it's hilarious. So that'd probably be my favorite tool just because I use it like literally every single day. It's fantastic.
Yeah, if I didn't have a mill, the 301 was actually the first thing that came to my mind.
Yeah, and it's like $300+, and that's obviously a lot, especially if you're not doing like a ton of electronic stuff. But man, when you're working on boards every single day, it's worth it, man. It pays for itself, like in the first 2 projects. It really
In
does.
the first single solder joint, you're like, all right, yep.
Okay,
Yeah.
I gotta look into that.
Yeah.
I have a very similar one. My favorite tool is my direct heated soldering iron. It's a JBC with internally heated tips, and it's just soldering is a completely different process with a direct heated tip. It's like normal soldering irons. They're indirectly heated, so you have like the handle and a heating element sticking out of the handle, and into that heating element you fit the tip that you're using to solder, and it's indirectly heated because heat gets transferred from the heating element through the whole tip to the free end of the tip where you solder.
Yeah, there's an air gap, is what you're saying. Is there's a
Yeah,
ceramic
there's an air
core.
gap, and the screw, and there's oxidation, and like the sensor is not where the soldering happens. It's a couple of inches back, and the internally heated ones is like you have the tip right next to it, the sensor and the heating element, and it's when you're soldering with a regular soldering iron, there's a heat curve. Like you start with too much temperature so that you can dump energy heat quickly into the soldering joint, and it cools down during soldering. So you always have to, you're temperature surfing all the time. And with the direct heated tip, it's ready. You switch it on, it's ready within 10 seconds, and it's the same quality through all the tip, and all these the ground planes, the through platings, the speaker connectors, anything. I would not touch a regular soldering iron again if I wouldn't really have to, but like I can feel you, Void, with the desoldering gun. I think it must be the same feeling. It's like there's no going back.
Oh yeah, absolutely. I actually recently got a directly heated soldering iron, so I know exactly what you mean. I used a Heiko 888D for about 2 years, and I ended up moving up to a 951, the removable tips, and it's fantastic. It's a serious step up from.
So all three of us have the entry level direct heated competitors. You've got the JBC, you've got the Heiko, and I have the Pace.
Yeah.
They're all around the same price, and
I think the JBC
phenomenal.
is a bit more than
No, the JBC, they came out with a newer one that's like the same price.
Oh.
I have the analog one still, because I didn't want the digital one, because
Yeah.
you see the point.
Mine's digital, and I like how I have temperature presets. I can just hold the up arrow, and it'll no, it's not hold. I press one button, and I can switch between 500, 700, and 800. That's usually where I keep it, 750. And another advantage for a direct heated iron is you can solder at lower temperatures. There's less hysteresis and more efficient power transfer, which is what Dave was talking about.
Yeah, absolutely. And one thing I'm looking forward to is when I'll get like deep scratches in my skating skis, in the base. You can actually set them on very low temperature, like down to 160 degrees, I think, which is around where PTEX melts. So you can use PTEX sticks with the soldering iron. I will be getting a separate tip for that one because they make really wide tips. So you can repair your ski bases with your directly heated soldering iron.
That's brilliant. That's like the sous vide and the ultrasonic cleaner.
Yeah, the sous vide and the ultrasonic cleaner. Oh, that was so silly. For those who don't know, I have an ultrasonic record cleaner to clean my vinyl records, and it occurred to me this thing has like a heating element, so you can heat up the ultrasonic cleaning bath to like 40 to like body temperature is usually what I'm using for cleaning vinyl. And it occurred to me that I could just put an aquarium pump into the thing and run the heating element by itself without the ultrasonic feature. And then it's the perfect sous vide cooker. So I sous vide cook steak in my ultrasonic record cleaner. And there's a video from the Munich hi-fi show where I'm talking to the Frem Lord, to Michael Fremer, about that. Yeah.
Yep. that was hilarious. It actually works as a sous vide.
Was it good?
Oh, it works. It works perfectly as a sous vide cooker. There's a timer. The aquarium pump is going strong. It goes up to like, I don't know, in Fahrenheit, 60 degrees, like almost twice body temperature, which is used for cooking steak usually. Yeah, I will not get another sous vide cooker, and I will also not get another ultrasonic record cleaner. I'm a happy camper.
That's brilliant. Yeah, it's so another thing about direct heated irons is the price of entry has dropped significantly in the past few years. Not only
The
with higher
USB
end,
one.
yeah, not only with like full on stations, but now you have the TS100 and the TS80 devices, which are like $70, and they pretty much perform as well as what we three are using, but they're entirely handheld and they can even run off a battery.
I have the TS100.
Oh wow, yeah, dude, that thing's awesome. That's what we
Yeah, I love
recommend
it.
to everyone.
Yeah, which would probably be one of the next question. What would we recommend to someone who wants to get into DIY? Our recommendation would probably be seriously think about if you can afford a directly heated soldering iron, because it takes so much frustration out of it. There's no cold solder joints. There's no, yeah, it's so much easier. There's no guessing. There's no waiting around for the iron to heat up. It's these are real game changers. The direct heated.
It works like it should. That's the theory, and it's implemented. It's brilliant.
Well, since you mentioned that, Dave, let's get into some questions about kind of the industry and that kind of thing, and audiophiles and things like that. So these are kind of some of my questions. So yeah, so for audiophiles that are looking to explore DIY, what advice would you have for them? Like, what should they? How can they get into it? What should they do? What should they read? What should they build? Etc. Etc.
I'll just keep talking. So when I started out with DIY, I read something that really stuck with me, and it was like, if you want to be an art critic, go look at a million paintings. It's apparently a thing they say. So if you want to there's two things. If you want to get into electronics, go look at all the circuits that you can find. Go look at all the audio circuits. Learn some basic electronics. Look at a lot of circuits. It will go click. You will see how the current flows. You will see how they work. First, it's parts of the circuit, power supplies. Then you really see the whole circuits come alive. That's the electronics part. With DIY, you don't need to really fully understand electronics, because these days there are kits you can buy which are really complete with pictures, build guides. You get all the parts. I don't know, when I started out, or when we got into electronics, it was you had to like look around for circuits. You had to shop around for parts and everything. There weren't really any kits or something. So to sum it up, my advice for someone who wants to get into DIY audio is learn some basic electronics. There's YouTube videos, there's Wikipedia articles, there's lots of resources. DIY channel here at Sonic Visions. Learn some basic electronics and buy a kit that is well recognized, that is known to work. I think it's important to get one or two builds finished and working before you start tweaking them, before you start doing your own designs. And I think it's really worth it, because at some point, when you have the skills and knowledge, you can build things that you can't buy.
Yeah, that's really the
Nice.
end goal, is to build things suited for yourself. Things that you can't buy, things that you find that you could use that just aren't available, or you can't afford it. And a lot of times you can trade skill and expertise and clever engineering for cost. Like that, you can redistribute the cost instead of just being monetary. You can be smart about it and design around the budget that you've got, and you can still end up with something amazing.
Yeah, especially I mean, it's building cables or something. It's really nice starter project, and you can build cables that would probably cost you tenfold if you went the commercial route. And like same with amplifiers. It's but don't be fooled. It's not stopping there. So you can tell yourself you're gonna save money if you start DIY, but the truth is you'll end up hoarding projects and building one amp after the other, and you will enjoy it. You will enjoy it, but
Yeah,
be
the fact that it's
warned.
cheaper, it's not cheaper at all. A lot of times, if you're really trying, if you're set on a design, it's going to cost as much as it would to buy something similar. However, when you're done with it, you have creative freedom when you've built it. So it's obviously going to be a lot more rewarding. But the price you pay is directly proportional to what you receive in the majority of cases.
Yeah, there's a lot of investment costs associated with it because you obviously have to buy the tools and buy the equipment to even do anything. You know, the soldering irons, pliers,
Yeah,
etc.
I
You
think
know,
you can get into it for just like get all the tools to do your own work for under $200. I'm pretty sure, like high quality stuff, not just like if you're
Yeah.
just scraping the bottom gunge of the barrel, um, you can do it for like $5. But yeah, just find some soldering iron on Alibaba and some fake solder and just go at it. But if you want to do it right, I mean, you can do it right. You get a $70 iron, you get MG Chemicals solder, MG Chemicals flux, you get a helping hands fixture, you get some nice pliers, some nice tweezers, heat shrink tubing, a tiny heat gun. You're in for maybe 100, maybe under $200.
But that
That's
will
Yeah.
very
last
good.
for years.
Yeah,
Yeah.
that the equipment itself will last for years, and the skills you gain will serve you for the rest of your life, which is the most important thing.
And it's
Yeah.
I think it's a very rewarding hobby because the soldering, the building, it's for me, it's very calming. It's a creative outlet, and I mean, you build something awesome that you get to enjoy many hours. And I mean, you've built something. That's something you can be proud of. That's something you can. It can be nice to look at if you have the machining skills.
Yeah. Or you could just buy cases off eBay and hope they're actually sized properly.
You can modify them with some caveman technology.
Yeah, absolutely. There's there's another thing I'd like to mention when it comes to something like this is like you are going to fail at some point. There's going to be some period where you build a project wrong or you get something wrong, and messing things up is pretty much inevitable. Like you're gonna screw something up. Like when you're building something from scratch and you've never done it before, you know, there's that pretty high chance that something is gonna go wrong. But at the same time, you learn from that. You know, you can use those failures or those screw ups to to learn off them. You can build from that, and you know, it's popular to talk about DIY in the sense that like, oh, you're building your own things and you're making them how you want them to be, and it's awesome. It's a transformative process. But there's also like there's gonna be headaches and there's gonna be hiccups, and I think more people should be a bit more mindful of that because I have seen people try to DIY things and they end up like either completely giving up on a project or even giving up on DIYing itself. Like they just say like, you know what, this isn't for me because they weren't really salient of that. So I think it's important to be mindful of stuff like that going into a hobby like this. You know,
Yeah,
there's a
that's
learning
something
curve.
very important to keep in mind, as well as like through studying the science of failure. I think that's like the most important and powerful learning tool in your library.
Yeah.
You become
know,
a
it's
very
obviously-
clever engineer.
Obviously, you don't want to beat yourself up over it, but just be mindful of that. It's always a possibility. I mean, I've been screwing with stuff for years, and even I still mess things up, and so does pretty much everybody that I know that does work like this. It's just
Absolutely.
it happens.
Except if you're a robot.
Yeah, if you're a robot, then you just breeze through everything. But that's not how it works for most people. So
I just want to get into the value question again. You guys talked about that. You mentioned about how it's not really cheaper for a couple of reasons. I think one reason was that you start hoarding projects and spending money on lots of different projects. And so I wanted to just explore that a little bit. So what comes to mind is, the Electrocution amplifier kits. And Herb Reichert, in his review on Stereophile, he said that the Electrocution sounds like a $20,000 amplifier, but it costs $2,000 because you built it yourself. So things like that and things like kits in general, is it the case that you're pretty convinced that there's never a greater value proposition compared to commercial items? I just want to revisit that. Do you think there is, putting aside, buying multiple things, let's put that aside, but just the notion of, you building a kit and then putting that against commercial offerings, is there higher value there? Can a kit like that perform as well as something that's a lot more expensive that's commercial because of dealer markups and distribution costs and assembly and all that kind of stuff?
Well, monetarily, yes, you can build something for dollars on every metric. Something that costs $40,000, but that's not a good basis, because there's a lot of stuff that is very expensive and very bad. There's a lot of stuff that's very cheap and very good, and it's a spectrum. So what you're saying is, like, there's good stuff for $2,000, $20,000, and then there's good DIY stuff that's about the same level for a tenth the price. Well, it's a tenth the price if you put a dollar sign on it, but if you consider the amount of time and energy you're putting
Right.
into building it
Right.
and developing your skill set, and you could be doing something else. You could you could go day trade and make that amount of money and then buy that amp,
Right.
But
yeah.
the result of building it yourself is not only do you come out with something beautiful and amazing and custom, you've also improved your skills in this area. So by practice, you learn a lot, and that's something that will stay with you forever. So I think the value is, like, it's not only just in but it's also in, like, self-development, skill development sort of aspect. You get a new perspective on electronics. You now understand, like, how parts of your car work, how your refrigerator stays cold, like how the touchscreen works on your phone. Just through logical thought procession, you can start to, like, develop the neural pathways for understanding things that were normally not even considered. That's why I like electronics. That's where I think the value is in doing it yourself.
Do you see more and more audiophiles get into electronics and get into DIY? Do you see that happening? What's the future of DIY in hi-fi audio?
I don't know. Dave is more active on the forums. I just build stuff.
That's what I was what I would have started with. So there's the DIY audio forum, which has a couple thousand, like many thousand members, and there has been, over the past 2 or 3 years, I would say, people had a lot of spare time and were locked up at home. There was a huge influx of new members from all areas, I would say. People who, like, know their ways with commercial gear, people who start out fresh with electronics. And what we're seeing is an abundance of DIY kits, DIY parts, DIY supplies, enclosures, places where you can buy electronic components with minimum effort. Like I have never seen that before, and I think I've been on DIY audio since 2004 or something, or 2005, and it really went the popularity of DIY audio. I think it was far from linear. It was far stronger than linear over the past couple of years. And coming back to the question about the quality of a kit, I think if you view the kit, a build kit, as the thing that it is, it's pretty much an unsupported product without the overhead, without the returns. It's pretty much it's R&D and a circuit board and a couple of parts, and without the labor and without the costs associated with someone doing labor for you. So intrinsically, you should get better value for the finished product as compared to commercial offer, but you have to put in the effort and also the risk that it won't work. But we're seeing kits getting better and better every day. It's really strange. I'm building. I'm mostly buying PCBs and modifying the circuits, and it's the integration of all the DIY, all the parts of DIY, like getting the parts, getting obscure parts, getting matched parts. There have been companies like Linear Systems. They develop new active devices. I mean, they're cloning the Toshiba parts, which are no longer in production, but there's efforts on all fronts, if you want to say so, for DIY audio and audio electronics. It's really strange, and the industry is shifting away from all the bigger parts with the bigger dies and the through-hole components. It's all shifting to SMD, but the DIY area is still it's through-hole components and new manufacturers. I mean, you can buy flavors of resistors that you wouldn't imagine that people would actually buy, but it's really strange, and I'm wondering if we're seeing peak DIY or if there's still room to grow in terms of quality. I don't know, but it's the how do you say, the stuff that's out there is amazing, and it's easier to get into than it has ever been before.
Yeah, that's another thing, is the price of entry has been slowly decreasing throughout the years, which is something that I've noticed. Now you can really just get everything, including a kit, for like nothing, for a chump change. And there's some schematics that are so easy to make, you don't even need a kit. And there's support. And another thing is the bottlehead offerings there's a moderate price of entry. I mean, the bottlehead crack is like $400, so that's not cheap. But the support around that kit is insanely good. It's actually the best I've ever seen, because they have their own bottlehead forums, and if you have any problem, you can go on the forums and they will solve it. Done within 24 hours. They'll just ask you, measure, boom, 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 measure voltage here, there. What does this look like? Done. Problem solved. And I think that's an amazing thing. So when you're paying for a bottlehead kit, you're also paying for like the community aspect and the reassurance that you're not alone, and there are people who are going to make your amp work, whether you like it or not. They will tell you what's wrong.
So to kind of answer your question, Asmod, I would really like to see more audiophiles getting into DIY, simply because they will get a better understanding of the components they're dealing with.
Right.
And then they can have more focused demands for what they want to see in a commercial product. So they become, how do you say, they will become more competent customers.
Yeah, that would be really good.
Yeah, I think there's just something cool about, as you guys have said, building your own thing. I recently built the Bottlehead Crack. That's the first thing I ever built, and yeah, every time I listen to it and look at it, I just feel, it gives you this feeling of satisfaction that you made it, and it sounds so good, and wow, how did I, somebody who has basically no knowledge of electronics, how did I make something that sounds this good? That's the cool thing about DIY that I found.
Well, yeah, that's another thing is like, it really is so much more rewarding when you make something yourself rather than buy it. Because when you buy it, you get a rush and then it wears off. Then there's always something else. But when you make it, you get a rush, and if it starts to wear off, you're like, all right, I'm going to make it better.
Right.
You can just do it. And that will never wear off.
And you got exactly the right feeling. When I'm getting up in the morning, I'm looking forward. I'm getting up early so I can spend time listening. So I'm looking forward to using my gear in the morning, and it's like you said, it's like, I can't believe I built that, and it's still working. It still has not caught on fire, and it's and this doesn't wear off. It's you built that. You can't. It's irrevocably yours.
And even if it wears off, if the piece of gear breaks, then you get the rush of fixing it. So it's cyclical. There's always an avenue.
What was funny was there's something about me breaking something that I made, which was when I built my B1 preamp, I was using an RCA jack for the 24 volt input. And it was, where this is going.
Yeah.
It was right next to all the other RCA jacks on the back of my preamp. So obviously what I did was I plugged 24 volts into the input of my B1. And I was plugging in some other RCA. I'm like, why is this thing shocking me? Why am I getting shocked? And I found out that I had blown up my B1. And what I did, I looked at the circuit, and I found that putting 24 volts on the input isn't going to really damage anything, except for when you turn it off, it's going to drain rapidly and destroy a diode in the power supply. So all that broke was this little diode from when I unplugged it. And I panicked, and I bought all the parts to repopulate the B1, and the entire thing came out to like $47. The whole preamp. I can build another one now.
Just buy another board, dude. You gotta have two of them now.
Let's send you a board, Pete Parker.
But the case I made for this B1 took me like a month. I can't do it any other way. I'm stuck in making it the best possible thing I can do.
Yeah, another month's a month.
Yeah, what's funny is like the materials for the case were probably like $14. But it came out like this gorgeous polished aluminum rod with gold jacks and cherry wood, and turned aluminum feet and no screws. I had no screws on the wood. I actually have hidden screws underneath.
Awesome.
That's a fun thing in engineering, is to hide screws and still make your thing not garbage.
Yeah, that's the cool thing about engineering and DIYing. You can kind of just do whatever you want, really.
Yeah, full creative freedom. Look at any Bang & Olufsen piece of equipment. You will not see a single...
Yeah, that's true.
Yeah. It's just a block.
Very sleek.
Yeah.
I think the prospect of also modding things is really interesting. Like if you build something, you have, some comfort level with, what's in there, and then when you kind of read about mods and kind of adjusting things and putting better components in, because a lot of times when you buy commercial products, they don't have good components on in the piece of gear or whatever it is, and when you are doing something yourself, I mean, you can take the time and research components and put the parts in, and then you can hear the result. And I think that's also something that's very interesting to me.
Yeah, I mean, that's just another dimension of creative freedom. And that you don't have to stick to the manufacturer's design. You don't have to use exactly what they sent you. There's nothing telling you what you can and can't do.
Right, yeah. Cool.
Yeah, modding is another fun aspect of the hobby. Just beefing things up or changing the flavor. It's all up to you. I mean, there's with commercial gear, you always have the resale value question. But even then, if you replace coupling caps, or as Void is doing, if you recap a unit, it's breathing new life into things. It's and you get that confidence with DIY. It's like you fix things, build things, modify things.
That's another thing, is like if you do a very good job, especially with mods, you are actually increasing sales.
Yeah. There's a pretty big market, especially for older equipment, for things that have been rebuilt and things that have been brought back to like operating spec. Like a Macintosh power amp that's been rebuilt by like a reputable guy will sell for literally like $1,000 or more than it otherwise would, even if the thing's worth like $1,800.
Yeah, just
like,
plus
you'll get like
1,000.
3. Yeah, you'll literally get like 2,800 or 3 if it's been rebuilt, because there's value in that, So the sky's kind of your limit with that sort of thing.
Except if the guy does a cracked out job, but then again, it'll still sell for a lot, and then the guy will get it and break.
I don't want to get into that, man. I got some.
We've got some horror stories,
man. I've seen some shit.
Parker, remember that audio research Ref 40 that guy modded, and he added like so many capacitors to it.
Oh, the stuff that was just like hanging out, free balling.
And then you said, yeah, he effed that up proper, and he had just like he had like wood boards and then caps on them like all over the place. It was two chassis preamp.
I saw recently, I hate to talk bad about this, but I saw in our IEM's channel a link to someone who had modified a Sony Walkman digital audio player, and the guy just murdered this thing. And I'm realizing like he's charging money for this hack job. That's something that we should understand better, and I think if DIY will actually help you understand that stuff better.
Yeah, because when someone like me or Parker sees something that's been hacked up, it's like we immediately know, like, yeah, that thing's messed up. But most people don't really know that, because they don't have the internal knowledge for these certain things to really be able to identify that. So if more people did more DIY related things, they'd be able to spot those kind of things better, and those types of people wouldn't be able to make a business out of, effectively ripping other people off, and ripping people off, pretty bad thing. So it'd be pretty nice if that stopped happening, but I don't know. I'm not too hopeful. I'm going to be real here.
No expectations.
All right. Well, that was an awesome episode. I really thank you guys so much. Any final words? Anything you guys want to say to the audience before we wrap it up?
Yeah, pick up a soldering iron.
Yeah.
From the wrong side, from the right side.
From the right side. or the wrong side, and then you'll learn which side you're supposed to hold.
Yeah, stay away from wall power. That's all I gotta say.
Yeah.
Or it'll wake you up if you're not already awake.
Respect electricity. It's one thing putting together a circuit while it's obviously powered off. Hopefully, obviously powered off. But it's another thing to work with mains voltage, and that takes experience and a lot of respect. It's something you do not want to mess with. So, yeah, it requires a bit of studying and maybe make a will or something.
Yeah,
Huh.
trial and error is only acceptable to a certain degree where you can actually like elevate the error to a point where you are no longer here.
Yeah. Well, but that's where kits really come in handy because they have it figured out how to work with mains voltage. If you build equipment from scratch and do the mains wiring and everything yourself, that's a bit of a different story. But with kits, it's usually well documented how to do it safely.
Yeah, start small.
Yeah, that's probably good advice. Yeah.
Yeah. Do a CMOI, then you won't hurt yourself.
Yeah, you can even probably lick the whole circuit without doing any real damage.
Except for my power supply with enough capacitance to start a small house.
Yeah.
All right, guys. Thanks so much. I really appreciate it, and I hope we can do it again. This is kind of we haven't done a DIY kind of style podcast, so hopefully you guys can join us again another time.
Yeah, well,
Yeah,
thanks for having us.
Yeah,
Thank you for having us.
Absolutely.
We were usually more folks in the DIY channel. I don't know where they are today, but hopefully next time.
Yeah.
Yeah.
We should get more guys in here.
Yeah, we'll set up another one, and hopefully we'll get some more discussion. Thanks a lot, guys. You guys take care.
All
Excellent.
right. Peace.